So this topic is about linear equations in one variable. So before we discuss about linear equations in one variable, let's come back from algebraic expressions or algebraic equations. So an algebraic expression was expressed in various forms where we had a one term which was called monomial, two terms which was a binomial, three terms with trinomial. Similar way, we have some algebraic expressions which are defined through their degree or the power of x. Now those are the algebraic expressions which define the linear equations or any other equation in one variable, two variables, or etc. So let's see what exactly is a linear equation. So the definition of linear equation is before we understand a linear equation, let's try to understand the degree of a linear equation or degree of an equation. For example, if I take some equation or an expression, I say that degree of this is 2. The highest power of x, which is in the given algebraic expression, is called degree. So now let's see the definition of linear equation or a linear expression. So in this case, if I take the expression as 3x squared plus 2, I find that the degree is 2. Now what is degree? Degree is the highest power of the unknown variable in an entire expression or an equation. Now in this case, I find that the highest power of x is 2. Therefore, degree of this algebraic expression is said to be 2. Now let's take one more example of x minus 3. So in this case, I find that the highest power of the unknown variable x is 1. Therefore, the degree of this expression is said to be 1. So there are various equations or expressions which have various degrees, and those degrees define the linearity of the equation. So let's come to the actual definition. So when I want to define the linear equation, an equation whose degree is 1 is called a linear equation. So an equation where the degree is 1 is called a linear equation. Say for example, I take x plus 2 equal to 0. This is an equation because I equate it. This is an expression because I cannot equate this. So in case of this equation, this algebraic equation, I find that the degree is 1. So therefore, this algebraic equation is called a linear equation according to the definition, which says that the degree must be 1. Since the degree is 1, this algebraic equation is a linear equation. Now let's take one more example. Now in this case, what is the difference I find between the previous problem and this? I find that there's only one variable x here, but I have two variables x and y here. So let's decide the degree of each of the variables. So in this case, I find that degree of x is 1, and in case of this, degree of y is also 1. So this also satisfying the definition of the linear equation, which says that if the degree is 1, the given equation is a linear equation. Therefore, since the degree is 1 in both the cases of the unknown variables x and y, this algebraic equation is also said to be a linear equation. But the difference being that this is said to be a linear equation in one variable, this is said to be a linear equation in two variables. The one variable here being x, the two variables here being x and y. So this is how we define the linear equations, and we just justify the one variable or two variable concept by identifying the number of variables available in that linear equation. But finally, the definition says that if the degree is 1, then that algebraic equation is called a linear equation. One variable in this case, two variables in this case. So let's take one more problem. Now this is a linear equation because each of its degree is 1. degree of y is 1, degree of z is also 1. Now we can call, by going with the previous two examples, I can call this as a linear equation in three variables, the three variables being x, y and z. So there are various types of linear equations which can be expressed in different forms as one variable, two variable or three variable. So in this initial session of the topic, we are going to discuss about linear equations in one variable and how to solve them. So before that, linear equations are split into two forms. One variable and two variable. The three variable linear equations, of course, are not discussed in this part of the syllabus, but it comes in the higher classes when we go in the future sessions. So linear equations are split into one variable and two variables based on the different types of problems which we are going to discuss further. Now, the first concept of what we're going to discuss in the one variable concept is solving of linear equations. We'll see how we can solve the linear equations, of course, in one variable. First, initially, we're going to discuss about one variable concept. So my first topic of discussion here would be solving of linear equations in one variable. So for example, I take one of the problem with this. I clearly understand that this is a linear equation in one variable because the degree is 1 and the unknown variable here is x. There's only one variable. So this is a linear equation in one variable, which is x. Now, when I mean solving of this equation, indirectly I mean finding of the unknown variable x. So I want to simplify this further to find the unknown variable x. Now we all know it's quite simple here that when you want to solve the linear equation, always remember, if I'm solving the linear equation in one variable, that one variable has to be kept on the left and all the remaining terms should be taken to the right. That is how the solving process is done. Say for this example, x plus 7 equal to 0. This is the unknown variable x and this is the constant 7. So for solving, the first step which I proceed with is taking the unknown variable x to the left and all the constants to the right. Therefore here this happens to be x on the left and then plus 7 comes to the right as minus 7. And this is how this solving is done. Of course, this is a very simple problem, but the method of solving starts with taking all the unknown variables to the left and all the constants to the right, and then solving to get the value of x, in this case being x equal to minus 7. Next, if I wanted to solve this problem, so in this case, also this is a linear equation in one variable because the variable here is x and clearly its power is 1. So for this linear equation in one variable, I'm going to solve keeping in mind that the first step is taking all x terms to one side and all the constants to the other side. Therefore, in this case, minus 2x remains on the left and the constant which is independent of x comes to the right with 4 fixed on the right side and plus 3 coming to the right side as minus 3 or negative 3. This is how I take all x terms to one side and all the constants to the other side. Now after this, I identify that this is negative 2x equals 4 minus 3, which is 1. Then again I have something multiplied to x, so that I want to bring this constant to the right and then simplify to get x. So therefore, I get this to be x is equal to 1 divided by negative 2 comes to the denominator, the product comes as the division, and then finally this is minus 1 over 2. This is the value of x. This is the solution for the given linear equation in one variable. So when you want to solve the linear equation in one variable, it's very simple. The first step which you're going to follow is take all the unknowns to the left and all the remaining terms to the right, and then find the value of x. Now let's see one problem where I have fractions involved in the linear equation in one variable. Now immediately identify that the unknown variable here is p with its degree as 1. Therefore this is a linear equation in one variable, and that one variable is p. So if I want to solve this equation, or if you want to find the value of p, then I take all the p on the left and all the constants on the right. So that can be done by keeping p fixed here, so that I get p on the left and 11 over 3 minus 5 over 3 to the right, plus 5 over 3 comes to the right as negative 5 over 3. So that immediately I take LCM and I get 11 minus 5. Then 11 minus 5 immediately gives me 6 by 3, which is 2. So this is the value of p, which is the solution for the given linear equation in one variable. Now I wanted to know whether my answer is correct. How do I know that p is equal to 2 is the right answer for the given equation? So this can be done sometimes by verifying. You can randomly verify in the rough work, or if the question is specifically about asking verify the answer, you must show the steps on the board. Verification is very important because you should know whether the answer what you got or the steps which you have worked out is right or wrong. So therefore, if I go with the verification, so let's see how verification can be done. It's very simple that verification is nothing but I substitute the value what I get as the final answer into the given problem, and that should be exactly satisfying, or it should be universally true. So therefore, I just got the value of p in this case of the problem as p equal to 2. Then I substitute this on to the given problem. Substituting p is equal to 2 in 5 by 3 plus p is equal to 11 by 3. I just wanted to see if the simplification on the left hand side gives me 11 by 3 on the right hand side. Let's see if I get it as an identity. So let's substitute and see if I get the identity here. So in this case, I just take p as 2 so that I get this to be equal to the identity 3. But this can be done by taking the LCM, which is 3, and 3 times of 1 is 5, and 3 times of 2 is 6, which is identically equal to 11 over 3. So immediately I get this to be 11 over 3 is identically equal to 11 over 3. Now because I got the left hand side equally as the right hand side, therefore the value which I obtained as p equal to 2 is very much true. This is how the verification is done. Therefore p is equal to 2 is the perfect solution for the given problem. This is how the solutions are worked out. So it's the perfect solution for this. So this is a random practice of verification which we need to do for every problem, not only for this topic but for many problems which we do in mathematics, because most of the times the students get into the rush of doing many mistakes while solving the problems, and to overcome that mistake sometimes this has to be verified. Now imagine I got p is equal to 3 here by default in solving. Then when I substitute here, I find that both are not equal. Then I understand that somewhere my process is wrong, and then I try to just reconsider in finding out where I have done the problem wrong. Then I can rectify the mistake and do the problem correctly. So verification is very important for every problem, but the verification should not be wasted with more time, but randomly worked out in the rough work through a quick process, a very quick process. Yes. So this is one of the example which makes us understand on how solving can be done along with verification. So let's see one more example which can be worked out using the process. Now in this case, let me just slightly modify the given problem where I use the unknowns both on the left hand side and the right hand side. Say for example, I have 2x minus 1 is 5 minus 3x, and I wanted to solve this equation. This is very much a linear equation in one variable because I have one variable here and one variable here, but both the variables are same, which is uniquely x. Therefore, this is a linear equation in one variable x. Now, how do I find x, or how do I solve this equation? By taking all x terms to one side and all the constants to the other side. Therefore, this can be done by just taking 2x on the left because it has x involved in it, and minus 3x comes to the left as plus 3x. So I extract all x terms to the left, then I take all constants to the right. Already I have a constant phi on the right, which can be written as phi, and negative 7 comes to the right as plus 7. So all the constants are taken to the right. Then on further simplification, I get 2x times 3x, 2x plus 3x in addition gives me 5x, and 5 plus 7 gives me 2l, so that the next step would be x equal to 2l. The product comes as division as 2l by 5. So my solution for the given equation here in this example is 12 over 5. Now you can verify by just substituting on the left and the right and showing that the left hand side is identically equal to the right hand side. Now this is how the verification is done for any problem. The process is this. So here similarly the verification can be done by substituting this x on the left hand side and substituting the same value of x on the right hand side and showing them identically equal. If they are not identically equal, then the answer which I have obtained would be wrong. That is how we recheck the process by verification. Now I wanted to solve this equation 2 times of L plus 1 minus 3 times of 4 minus L equal to 7L plus 3. Now this is also a linear equation in one variable, the unknown variable here being L. Now in this case also we just try to expand the brackets and take all the unknowns to the left and all the remaining terms to the right, and then we solve for L. So let's see how we can do for this particular problem. So taking the left hand side, I can expand the bracket by just multiplying 2 to each of the terms, so that I get 2 times of L, which is 2L, and 2 times of 1, which is 2, minus, similarly when I multiply 3 to each of the brackets, I get minus 3 times of 4, which is minus 2L, and minus 3 times of minus L, which is plus 3L, that is equal to 7L plus 3. Then in this case, I have 2L terms here, which I'm going to further simplify, so that I get 2L plus 3L as 5L. And this would be 2 minus 2L, which is negative 10, is 7L plus 3. Then my next concept is to take all L terms to the left. So I just want to take this here and this to the right, so that the next step would be reduced to 5L minus 7L is 3, and negative 10 comes to the right as positive 10. So this would be nothing but 5L minus 7L would be negative 2L, the negative sign because the highest of the two terms is minus and one of them is plus and one of them is minus, so we subtract with the highest sign, with the sign of the highest value put in before. Next, 3 plus 10 is 13, therefore I get L as 13 by negative 2, which can be written as minus taken to the numerator without affecting the equation as negative 13 over 2. So this is my value of L, which satisfies this equation. So this is how we solve, and verification is done by substituting this on the left hand side and the right hand side and showing that they are equally identical on both sides. Yes. Now coming to the linear equations in two variables, we already defined what is a linear equation in two variables. If you have two variables identified in the equation with degree, each of the degree being 1, then such a algebraic equation is called linear equation in two variables. Now we have seen how to solve a linear equation in one variable. So let's see if we can solve a linear equation in two variables. Now here there's one very important concept which we're going to discuss out here. Say for example, I have x plus y equal to 7. Now this is clearly a linear equation in two variables because each of the degree of x and y is 1 and there are two variables. Now in case of linear equation in two variables, I cannot solve for x and y with only one equation given. This is a very important concept in mathematics or in this topic. Now when you have two unknowns, you need to have minimum two conditions or two equations available. If you have three unknowns, you should have three conditions or three equations available. If you have n unknowns, we need to have n conditions or n equations available in order to solve that particular set of equations. So this is very important here. Therefore, if you have a linear equation in two variables, I need to have another condition through which I'm going to solve this. So for example, if I have two linear equations which I wanted to solve, I wanted to solve these two linear equations where each of the equations has two unknown variables x and y. So when I wanted to solve them, now I can solve them because there are two equations with two unknowns. Now this is the condition through which we solve. So how do you solve this is very important in this case. So when I wanted to solve, I just take all the variables column wise. I take them one by one together. So suppose I have x plus y equal to 7 and x minus y equal to 3. Then I take all the unknowns in one column one by one and then I solve. In this case, I add because I want to eliminate y. So when I add, the plus y and the minus y both get cancelled together. And here when I add x and x, x plus x would be 2x and 7 plus 3 would be 10. Then in this case, x would be 10 over 2, which is nothing but 5. So in this case, x would be 10 over 2, which is 5. So I got one of the unknown as x equal to 5. So how do I find the other unknown y? This can be found by substituting x equal to 5 in one of the equation, either equation 1 or equation 2, and then we get the value of y. Say here, x equal to 5, I would like to substitute in equation 1. Then I get 5 plus y equal to 7 because I substituted x equal to 5 in equation 1. So in place of x, I get 5. The rest of y and 7 remain the same. Now this is a linear equation in one variable. After I substitute the value of x, this has been reduced to a linear equation in one variable, which can be simplified by taking y to one side and all the rest of the constants to the other side. Therefore, I get here y equal to 7 plus 5 coming to the right as negative 5, and this when simplified gives 2. Therefore, y equal to 2 and x equal to 5 are the set of solutions for the given set of problems, the equations. So this is how we solve the linear equations in two variables. So when we just simplify, it is very simple that we either add or subtract and then find one of the variable, and that variable is substituted in either equation 1 or equation 2, and the next set of variable is formed, and this is said to be the solution of the given set of linear equations. So using these concepts, we'll see how the real life problems can be solved using the linear equation concepts. Say for example, I wanted to find, let me take the heading, how the word problems can be solved using the linear equations. In this case, I find that the problems are direct. Given a problem, we just simplify using various processes of what we have learned. But sometimes the questions are approached in a real life manner or given in the word problem format. Now, let's discuss the word problems, where we are going to identify the applications of linear equations in real life. This is very important because the questions are not given directly, but we are going to frame mathematical equations out of the given real life problem, and then we solve for the unknowns or the situations. So in case of, let's see one of the example through which how the word problems can be solved. In case of this example, the question here says that if sum of two numbers is 58 and their difference is 28, find the numbers. So in this case, I understand this question to be given completely in the word form, but when I convert this into mathematical equations, it is nothing but I identify them to be the linear equations in two variables. So let's see how. So because I don't know the numbers, this problem seems to say that there are two numbers whose sum is 58 and equally the difference is 28. But I want to find the numbers. So because I don't know what the numbers are, so immediately I take the numbers as say x and y. The unknowns are always taken in the variable form. Let the numbers be x and y. Now, if I take the numbers as x and y, now clearly the sum of those two numbers is said to be 58. The sum is plus. So therefore, sum is 58 implies x plus y is 58. Now, here the sum is 58, so mathematically it is x plus y equal to 58. Now the difference is given to be 28. So assuming that one of the number is greater than the other, so I here assume that out of the two numbers which are assumed as x and y, x is greater than y. Then in this case, the difference is 28, makes me understand that x minus y is 28 because x is greater than y, so x comes first. This being a positive difference, so I get this to be x minus y equals 28. So I have totally two equations here, where this I represent with equation 1 and this with the equation 2. Now I have two linear equations in two variables x and y, and I am going to solve this using the similar process as I have done in the previous problem. So going by the similar fashion, I just solve for x and y by adding the two terms. So in this case, when I add, my plus y and minus y gets cancelled, as in the similar case of the previous problem where x and y, plus y and minus y cancelled. So then in this case, x plus x would be 2x, and the addition of 28 plus 58 would be 78, 86. The addition of 58 plus 28 would be 86. Therefore, I want to find x, so I take x on the left and all the remaining terms on the right, so that I get x to be 86 by 2, which is 2 1s, 2 4s, 2 3s, which comes to be 43. Now when I get the value of x equal to 43, I substitute either in equation 1 or 2 to get the value of y. Therefore, substituting x equal to 43 in equation 1, I get x minus y equal to 28, so that this becomes 43 minus y equals 28. And then on simplification, I get this to be with the value of y. Now continued from there, so I want to find the value of y from that equation obtained. So 43 minus y equal to 28 would give me minus y equal to 28 minus 43, plus 43 brought to the right as minus 43. So in this case, when I simplify, I get 28 minus 43 as 15, negative 15. And then my y would be, on cancelling, positive 15. So I got the value of y as 15, and I got the value of x there in this case as 43. So these are the values of x and y which make me satisfy with sum of two numbers being 58 and the difference being 28. Therefore, the question is find the numbers. Therefore, my answer is the required numbers are 43 and 15. So you can do these kind of word problems using the concept of linear equations in one variable, in two variables, by this concept. The information given out here that sum is 58 and difference equal to 28 helps me out in finding the numbers in this form. So there are many problems through which the word problems can be expressed in a mathematical form and then solved for using the linear equation concept and then finding the numbers. This is very important in most of the cases where we do the real life problems. Now let's see one more problem where The similar word problem has some information. Now in this case, the difference between two numbers is given to be 8, and it is also said that if 2 is added to the bigger number, the result is 3 times the smaller number, and I have to find the numbers. Now because I don't know the numbers, as in the previous case, similarly I take, let x comma y be the numbers. Now assuming that x is greater than y. Now because I had to identify the bigger number and the smaller number, I assume one of them to be bigger. So in this case, I assume that x is greater than y. So x is the bigger number and y is the smaller number out of these two. Now let's convert the given information into the mathematical equations. Now the difference between two numbers is 8. Because the difference is positive, so I have the greater number coming first and the smaller number coming next. So I have the difference is 8 implies x minus y is the 8. This is one of the equation I have obtained from the first information of the problem. Now it is also given that if 2 is added to the bigger number, now my bigger number is x, so if 2 is added to the bigger number, then in this case I get the result to be 3 times the smaller number. So I have the result to be 3 times of the smaller number, which we all know that is y. Now in this case, I try to bring this in the similar format as that of the equation 1, with x term being the first and all the y terms being the second and the constants on the right. So if I just rearrange the terms, I get x and plus 3y to the left comes out to be minus 3y, and plus 2 if I bring it to the right would be minus 2, and this is equation 2. I take it as equation 2. Now in this case, I want to solve equation 1 and equation 2 to find x and y. It is nothing but two equations, two linear equations in two unknown variables x and y, for which I'm going to find x and y. So therefore, I just take one equation over the other, so that x minus y comes below this equally with all x terms in one column and all the y terms in another column, and then I'm going to solve equation 2 and 1. So in this case, I'm going to solve these two equations. So because the x coefficients are same, I'm going to subtract and then making them eliminated. So I want one of the variable to be eliminated, so I subtract. The subtraction gives me plus becomes minus, and minus becomes plus, and plus becomes minus, so that this gets cancelled in the subtraction. Now minus 3y plus y would give me minus 2 times y, and minus 2 minus 8 would give me minus 10 or negative 10. So in this case, the y value would be negative 10 over negative 2, with negative 2 in the product coming as the division. Now with this, both of the negative signs get cancelled, and this gets cancelled with 2 1s, 2 5s, so that I get y equal to 5. So I could identify one of the number to be 5. So immediately I can get the next number by substituting this in either equation 1 or equation 2. So let me take the simpler equation. Now here I suggest to all the students, try to substitute the value of y or x which you obtain in one part of the problem in the simpler equation. Do not take a bigger equation and waste your time. Now I identify that out of these two, this is the most simpler equation. So I substitute this in the simpler equation so that I get the value of x in a faster process. It saves time, and I want to spend the time in the most complex problems. So therefore, I substitute y equal to 5 in equation 2. In equation 1, my equation 1 says x minus y equal to 8. That implies x minus 5 equals 8. That implies x equals 8 plus 5. That implies x equal to 13. So I got the value of x, which is 13. I got the value of y, which is 5, which are the required numbers. Therefore, the required numbers here are 13 and 5, which satisfy the given conditions that the difference is 8, and when 2 added to the bigger number, the result will be 3 times the smaller number. And under these conditions, the required numbers are 13 and 5. So this is how the word problems are done using the mathematical equations and the applications of linear equations. Now, in case of this problem, the sum of two consecutive odd numbers is 56 and I want to find the numbers. So if I take the number, one of the odd number, I take it as x. Let the odd number be x. Then what would be its consecutive odd number? See, odd numbers are obtained by adding 2 to each of its previous odd number. Therefore, if x is the odd number, then identify that the next consecutive odd number would be x plus 2 with 2 added to the previous x. Now, if I have this condition of the two odd numbers being x and x plus 2, then I have identified from the given problem that the sum is 56. Therefore, sum is 56 implies my x plus 2 is 56. Now, I have the sum of consecutive odd numbers to be 56. So I have taken one of the odd number as x and I got the next consecutive odd number as x plus 2 with 2 added to that. Therefore, my consecutive odd numbers here are x and x plus 2. And the given condition here is sum is 56. Therefore, I have x plus 2 equal to 56. Then in this case, I get, simplifying further, 2x plus 2 is 56. So that 2x is 56 minus 2. That implies my 2x is 54. And that implies my x is 54 divided by 2. This gives me 2 2s, 2 7s, which is 27. Therefore, one of my odd number is 27. So that next consecutive odd number for 27 would be 29. That implies x plus 2 is 27 plus 2 is 29. Therefore, the consecutive odd numbers are 27 and 29. So this is how we identify the consecutive odd numbers for the given condition of the problem. Therefore, the numbers are 27 and 29. So different types of problems. We have seen till now we have seen many different problems in word problem format which have been with different conditions. So this is how there might be any problem, but ultimately it is that we have to convert the given condition into the mathematical equation and then solve. However complex the problem is, the method is the same for any word problem. Now, there are some geometry related problems which also use the linear equations in 1 and 2 variables. Now, in case of rectangle, we can find the dimensions of a rectangle or a square or a triangle using the concept of linear equations. And let's see this word problem, how we can apply this in real life. Now, it is given that the length of rectangular field is 8 meters less than twice its width, and we have to find the dimensions given that the perimeter is 56 meters. So let's try to convert this into the mathematical equations. But initially, because it is a rectangular field, let's draw a rectangle. We all know what a rectangle is. So if this is assumed to be the rectangular field, it is told that the length is related to the width with certain conditions. So because I don't know what the length and the width is, I just take the length as L and I take the width as B. Length, width or breadth is B. So using these two unknown dimensions, I'm going to frame the linear equations. So here it is given that the length of the rectangular field is 8 meters less than twice its width. So if I take twice of breadth, then the length is 8 meters less than that. So I understand this to be twice of B minus 8, which gives me the original length L. So my length L related to B would be L equal to 2B minus 8 using this sentence of the word problem. So coming to the next, I understand that my perimeter. So before that, let me arrange all L, B on one side and all the constants to the other side. So here this is understood as L minus 2b is equal to negative 8. So this is one of the equation which I have obtained from the first condition. Now, also it is given that perimeter is 56 meters. But we all know that the perimeter of a rectangle is twice length plus width. So perimeter is 2 into L plus B, which is by the formula and equated to 56. Further simplification will give me L plus B is equal to 56 over 2, 2 2s, 2 8s. So this comes out to be 28. Therefore, I have L plus B is 28 and L minus 2B is negative 8. Therefore, if I take this as equation 2, I would like to solve equation 1 and equation 2 by elimination process. Therefore, I write the equation 2 initially, and then below that I write the equation 1, which is already obtained here as L minus 2B is negative 8, which is equation 1. Now I'm going to solve these two equations by adding or subtracting, and then I get the unknown dimensions. So continued from there, I would like to solve equation 1 and equation 2. So what I do is I take the equation 2 here as L plus B is equal to 28, and then I take the equation 1 below that with all L in one column and all B's on the second column, and then I get this to be equal to negative 8. This is equation 2 and this is equation 1, and then when I solve, I identify that both of L's have the same coefficient, so I would like to subtract so that plus becomes minus and minus becomes plus, and this gets cancelled, and finally I get B plus 2B, which is 3 times of B, as 28 plus 8, which is 36. So taking only B to the left, I get 36 over 3, and then this on simplification gives B to be 12. So my width of the rectangle is identified as 12 meters. Then this on substitution in the most simpler equation, this being the most simpler out of these two, I substitute B only in this equation because my simplification process doesn't take more time, and therefore substituting B equal to 12 in equation 2, I get L plus 12 is 28, so that my L is 28 minus 12, which comes out to be 16, and therefore my length is 16 meters and my width is 12 meters, which are the dimensions, which are the required dimensions of the rectangle of this rectangle. So I get the dimensions using the concept of linear equations from the given word problem. So this is how a perimeter and area related problem can be solved using the linear equation. Even a triangle, there are many problems related to triangle, a square or a rectangle